Okay, so now what we're going to do is finish off the introduction to JavaServer Faces, talk a little bit about what it is, where it came from, difference between action and UI component frameworks. JSF is a UI component framework. I'm going to talk about the JSF processing lifecycle and some simple examples to show that. So here, as you'll remember from the Java EE description, are a whole set of tools that we're going to be using to build our applications, but the ones we're going to focus on right now are JSF plus prime faces, which we'll talk about in a later set of discussions, how they relate to what you've been studying in your tutorials, that is HTML, CSS, and JavaScript, and then talk a bit about Ajax, which is not a thing in itself, but actually a way of using JavaScript in a browser in a particular way to enhance the user's experience. And we'll get into a little bit of jQuery, which is a library of JavaScript routines that makes using Ajax much simpler. And in fact, Prime Faces uses jQuery extremely heavily to make the JSF tags of Prime Faces much more functional. So, what is it? It's an outgrowth of the servlet and JavaServer Pages APIs that we mentioned in the past. It's built on top of the Java servlet, so in fact those are still used, and occasionally you will write them. It's mostly replaced the functionality of JavaServer Pages, but if you'll notice in the diagram there is a reference to the standard tag library, that's the JSTL, and in fact there is some use in JSF Applications for the JSTL library. There's actually several of them that may come in handy, some that have to do with, for example, string formatting and things like that actually are quite handy. Again, like the JavaServer Pages, the HTML is not created from the servlet code, but in fact the JSF tags, other standard HTML5, the unified expression language statements, those are the ones with the hash signs plus the curly braces for evaluation, and then of course CSS and JavaScript are all part of JSF Pages. JSF Applications, really what they are a controlled flow of events that the user's web browser sends to the server side. The JSF environment reads those and determines what has to happen, and the way that you actually tell it what to do and how the user interacts with the pages is by putting special user interface widgets, which are those special tags like forms or a widget, or buttons or a widget, or links or widgets, etc. Then on the app server side, the web container is the thing that actually manages all of the phases of the processing lifecycle. The web container part of the Java EE app server, what it actually does is it parses your JSF pages into vanilla HTML, CSS, and JavaScript. The web container returns from that a new HTML screen, or perhaps pieces of HTML, or even data in some other format such as XML or JSON format to the requester. This continues the cycle, and then the client uses the JSF created buttons, links, etc. that they see in their browser to send the next round of data back to the server side, using usually either HTTP post verbs or get verbs. So what is it really? JSF is what you would call a UI component framework, and that is actually how it implements the model view controller pattern that we've been looking at. A way of thinking about it is, if you've ever done any Java Swing UI programming to develop user interfaces on your app, on your PCs, or your Macs, that is sort of an analogy for how JSF works for building web applications. In JSF, what you do is you design views using the view template language, which in this case is JSF. You create the model component using the various kinds of beans, backing beans, enterprise Java beans, and other plain old Java objects, and those hold both state information about the conversation, about the transaction that's going on, and also business logic which is used to modify the current state that the user has on the server side. Just as an aside, of course, if you remember from the enterprise tier and business tier description of Java EE, the low-level data access is below all of this, and in fact that is the function of the Java persistence architecture or API. That's the JPA, and those @ entity annotations which you use to map the tables, the relational table data, into your object data. And then where does the controller live? Remember, this is an MVC architecture. Controller, the thing that handles the requests coming in and the responses going back, is actually part of JSF itself. In other cases, you might have had to write this controller or a set of controllers yourself using servlets and other Java objects, but in this case JSF provides it for you, so you don't have to write any of them yourself. They are already it's already given to you as part of the environment. So here's an example of what we're talking about. You create the JSF pages as HTML5 files with an XHTML extension. Then you add JSF functionality by putting those UI components into those pages. You bind the components on the browser side to the server side using manage beans. We've seen that. The distinction between JSF manage bean and the CDI named beans, NAMED beans, but they're both ways of communicating back and forth from the client side to the server side. Then JSF also has the ability to put component generated events into the browser display, so that the things like a button press or a clicking on a link or any of the other standard JavaScript type of actions like on blur, on change, on load, all those things that you might be familiar with already, are also available from your JSF tags. Then the web container saves and restores the application state for you on the server side. So in other words, session management is built into this environment, so you don't have to actually do anything to make it work. Remember, that's a problem with HTTP because there is no state in the protocol that's maintained, so something has to do that, and in this case you don't have to. In fact, the Java EE app server is doing it for you. And then you can actually create new JSF widgets. You can actually essentially extend the language by doing what's called component customization. The benefits of using JSF: you have now the ability to do templating, which was not part of JSPs. That is the ability to put together a standard look and feel using facelet pages, and then introduce components that will actually read in pieces into those standard templates so that the look and feel is very consistent. You can use Java annotations. That makes it much easier to manage things inside of your JSF applications. There are implicit navigation rules. That is, how do you get from one page to another? We'll look at that in more detail, but the basic idea, of course, is that the manage bean returns a before we get to the bean side, the browser side for example, in the case of a button push, would call something on the server side, and then the server side would actually return a string, and that string by default is, for example, if it's in a button action attribute, that string would then be interpreted as a path to the next page to display. Obviously there's more to it than that, and our core JavaServer Faces Pages book goes into that in a lot of detail. But what it means is that you can do an awful lot of basic navigation around your application simply by using that model, and then you don't have to develop any special configuration files, though there is support for the more sophisticated kind of navigation rules that are also described in the chapter on navigation in the core JSF book. And then lastly, a benefit is that JSF has what you would call a lifecycle service manager, and what that does is it allows you to consistently do things like validating fields, converting them from one format to another, updating the model in a consistent way where you know that only clean data is being used to update the model, etc. So JSF at a lower level is composed of this package, which this is where the actual widgets are defined. There's a rendering model that says how are the components supposed to be displayed and manipulated. Then there is a conversion model that says how do you convert from one data type to another. For example, what we're referring to here is that all the data on a web screen is essentially in string format. However, the model on the other side is going to be, for example, if it's a dollar value, is going to be expecting to see a double type of value that it can interpret as a dollar value. So something has to be doing the conversion, and in fact it is JSF that will do that for you. Then you have a built-in event and listener model, and those will listen for all of those button pushes, link presses, and then all of those other kinds of JavaScript events that I was mentioning before. When you enter a field, when you leave a field, when you make a change in a field, if you drag something around on the screen, etc. All of those are available to you on the JSF side through the lifecycle manager. Then you have, as I said, a validation model. It says how do you define the exact values that a form, for example, should contain so that the user doesn't type in bad data. And then there's also, as we'll see when we look at validation in more detail, there are actually many levels of validation that you can use. The one that I was just referring to is actually built into the JSF tag system, but there are actually other kinds of validation you can also do, or you can use them in conjunction with each other. And one of them is the Java EE Bean Validation API, which actually allows you to put special notations on your Bean variables, the private variables inside of your beans, to say that oh, this string has to be no longer than 10 characters, etc. And that can work in conjunction with the validation model, and in fact with other validation components, for example the ones that are built right into HTML5 nowadays. So what is this difference here between this approach and maybe the more traditional approach? This is, as I said, is what's called a component-oriented processing framework. And the idea is that you as a developer are basically developing the interface, and then a lot of the work for how the interface is managed is being done for you, and how the request handling and response handling is being done for you. However, in an action-oriented web development frameworks, they are more what I would call procedural, in the sense that you have to focus on how to handle the requests coming in directly from the client. You have to manage how to effectively write your own controllers, and then do the dispatching, figure out what views are handling them, etc., etc. So it's good if you really want very fine-grained control over all of these things, but it does force you into often writing more code than you might want to, or in a sense it keeps you from focusing more on your business logic and your domain rules. So a couple of examples of tools that are more in this vein, more action-oriented: Spring MVC, Apache Struts, VRaptor. These are all Java environments that are of that kind. So in this case, you'll see that the browser sends the request in. There's a controller. The controller determines what actions are chosen, and then the model gets updated, and then a view gets picked to render the state of the model. So you basically have to write an action for each kind of interaction that the user has. There's usually a corresponding view for each one. Sometimes you'll see a direct mapping from the actions to the views right in the URLs in these kinds of environments. And oftentimes there's a lot of subclassing of the framework classes to define your particular actions and things like your forms. Now, in contrast to that is the JSF model, and JSF is not the only one of these, but basically the idea is that the controller here is written for you, and essentially what you do is you compose pages made out of these UI components, and then the controller, when it gets a request, knows how to manipulate those UI components to eventually create the requests to the model to update itself, and then also helps determine which view gets picked. So in other words, a lot of this is done for you, and you can focus on the UI pieces of the environment. So these frameworks are basically concentrating on the view. The view is represented as what is called a UI component tree, and that is a data structure that the system can then traverse and look for lifecycle events and then trigger on various things, etc. So the model is referenced directly from the view. Downside, there is overhead for managing all of these stateful components on the server side between from view to view. This is all, of course, hidden from you, but there is some performance implications of doing this for you. Other tools besides JSF, like Tapestry and Wicket, are examples of these kinds of frameworks. So if you want to compare the two approaches quickly, the component-oriented, this would be a JSF, for example, is event-driven, GUI oriented, and there is probably some learning curve because it is not standard procedural programming that you might be used to. There's less of the writing a lot of HTML, CSS, and JavaScript because the JSF tags actually embed a lot of the HTML, CSS, and JavaScript that the browser sees in them, and will do a lot for you. And that's even more true when you get to prime faces. In a sense, this is a purer form of the original MVC concept that came out of the Xerox Smalltalk work back in the 1980s, for what that's worth. There's a lot of the handling that you don't have to worry about in a normal HTTP request response environment. A lot of it is done for you. The UI components are not an add-on, but they are the major thing that you work with. There are many off-the-shelf components. That is, all the JSF tags are components like this. And then there is an ability, as I said, to add new components fairly easily. And in fact, tools like prime faces, omni faces, rich faces, ice faces, these are all examples of those plugins that allow you to extend the environment. On the other hand, the action-oriented is probably more familiar to you if you've ever done more conventional web programming. Would be easier if you're a manager to find people who've done it. It gives you much finer grained control over the lower level things, but on the other hand, it's more work to do that if you don't want to focus on the details so much. It is also, depending upon the implementation, it's an MVC. They're often MVC models, but you might have to do some more work to handle things like state management. There is no special UI components built in, though many of them have templating built in. And because they are basically API libraries that make these up, it's easier to perhaps to integrate other libraries and tools into them. However, in general, there's no special plugin mechanism the way there is for something like JSF. So what does it really do for you? It handles all the incoming requests for you. It decodes the request parameters that are coming in, whether they're coming in via post form parameters or using get URL parameters that are part of the URL string. It automatically will do basic validation prior to updating the model. In other words, the model will not be updated until the validations that you specify have been passed. It will automatically modify and save the model state for you, so you don't have to do that yourself. And then lastly, it picks the proper view and renders the web pages back to the browser in whatever makes the most sense for that particular client. So what are these apps usually include? A set of HTML pages with the JSF components laid out on them using templates is most common. A set of these tags that adds the components, a set of managed beans that act in the background. The backing beans, for example, are the ones that you bind the data on the HTML pages to the server side objects on the other side. And you can also have beans that act as in other ways, for example as action beans, so that they don't necessarily map one-to-one to a particular form, but they will actually do things and provide updates to the model. The ability to have or use a web XML file, this is actually not necessary anymore, though I find it's still a handy way of describing what's going on as in a configuration file, separate configuration file. And then you'll also find, assuming that you're using the Java Persistence API, you'll find a definition file, persistence.xml of some format, and that's actually used to help map between your objects and the underlying databases. Optionally, you'll also see things like the faces config.xml. The navigation rules would go in there, amongst other things. And you'll also, though many times in our cases it'll be empty, there is another file called a bean.xml, and these are all configuration files that you can use or to a large extent ignore, depending upon if you have a need for them. You can use them, otherwise you basically can ignore them in most cases. Then there would be custom objects. These would be objects that go beyond the standard tools that are given to you. You can create custom components, custom validators, custom converters, custom listeners. Listeners are those event listeners that will trigger based on certain things the users do. Those you can write yourself, and that's another way of extending things. Then there would be custom tags, UI components that come from other places. And as I said, the one we're going to be using is called Prime Faces. So that's a source of many interesting and useful UI extensions. So how does this work? Faces servlet, that is the name of the master controller. It's configured in the web XML file. Basically, it intercepts all of the requests coming in from your application and then dispatches them to Faces servlet, and that then will take control over running through the JSF lifecycle. So what does it do? It accepts the URLs, it accepts the path, it figures out what the view is, it compiles the view template to produce this data structure I was mentioning, the UI component tree, and that data structure is actually used internally by all of the other stages in the life cycle. Once that UI component tree has been built, it's saved for processing what are called postbacks, which is the term you use for going right back to the same page from the client. Now you might say, well, why would you be doing that? Well, the major reason that you do that is when they make a mistake or they have gone against some of the validation rules or the conversion rules that you're imposing on their inputs. What the system will do is it will use the tree to determine what the fields are supposed to be, and if in fact they don't pass validation, for example, then they will post back. They'll send it back to the same page for the client, except they will also send back things like error messages for the page to display. One of the byproducts of doing this that you'll notice, and it annoys some people, or it can be gotten around with some extra effort, is that if you look at the URL at the top of the browser page and the actual view resource that generated the last view, is that they don't always synchronize. In other words, the page that you're on in the browser is not the same that it displays up in the URL. And you might say, well, you know, I don't bother looking at that anyhow, so what difference does that make? But in fact, there is a point where you really want that to be the same, because in fact users will bookmark pages, and you cannot, if you're bookmarking a page, it has to have the proper URL otherwise you cannot get back to there. So this is an issue that comes up, and we'll address it as we need to, but just be aware that that can be a problem that you need to think about at certain points. But that's in exchange for all of the rest of this that's done for you. So here you can see this is in the JSF Java EE world. This is basically where the controller, the view, and the model live. The controller is basically the Faces servlet. The request comes into it. It then builds backing beans as necessary and reads from them as necessary. And these are the things that are mapping to the view that produce this request. Those backing beans interact with other business components. Those business components use these data access objects to get at the data from various places. The most notable one would be relational databases, but they could be other things like NoSQL databases or other sources completely. And so you've got, that's where the enterprise tier in our other model is being hidden away from the model, which really consists mostly of the backing beans and the business components. That is defining the current state of the world for that particular user. And then of course the Faces servlet, its other function, besides asking the model to update itself, is to then pick a view to render the current state of the model. And if you go to the right there, that is where the facelets comes in. It's where the JSF tag libs come in, other components like prime faces, or even the, as I said, the JSP standard library, the JSTL might come into play there, and then that view component is what actually would query the model, and vice versa. The model can actually notify the view of changes also. But ultimately the view is responsible for rendering the response and sending it back to the user. So there's the cycle in a nutshell from a JSF point of view. There's the controller, the view, the model, and the rest of the data sources, which are purposely hidden below so that you could easily swap them in and out as necessary. So the lifecycle management that JSF does figures out how a request is handled, how the response is generated. So it has to figure out which view to operate, which coordinate so that the UI components get the values from the user. It ensures the values are validated and converted properly. If the user triggered any of those events, it's able to determine that that happened and then do the right thing. It's responsible for updating the model, or at least sending notifications to the model to ask the model to update itself, which is the more proper way of thinking about it. And then it's responsible, as I showed you, for selecting and rendering the next view, which is then sent back to the user. Nice thing, you don't need to invoke any of this directly yourself. You can get down into fairly low levels to manipulate the lifecycle processing, but just generally speaking, you don't have to for the most part. There are two primary methods in this processing model. One is called execute. That handles the basic processing for a current request, and then the other is render, which renders the view. Okay, you don't actually call these are being called on your behalf. And there are a number of phases that are used to actually go through this entire process. In fact, there are 6 different components that every client request goes through. You can see the execute portion is the portion in the yellow here. Those are the first 5 phases, and the render portion is the last, and we're going to go into this in more detail. But basically, you can think of this as a cycle. It comes in from the client, a request, and it goes through step 1, step 2, step 3, 4, 5, and ultimately step 6, which is generating the response. The dashed lines, just to give you a heads up here, it's basically the life cycle can be short-circuited at any point. So for example, if for some reason the conversions aren't done properly, then there's no reason to go through all of the rest of the cycle except to render a response that says that there was an error. Okay, and that's where the error messages would get tacked on, and a postback would happen to take them back to fix the errors. And you can see that can actually happen in several different places in this life cycle. So during the execute phase, basically the UI component tree is either built from scratch if it's the first time for that page, or it is restored on the server side if that page has been seen before. The request parameter values are applied to that component tree. The conversions, that's the first thing that happens then, are attempted, and then the validations are matched against what the fields are defined as by you in your tags and in your custom validators. And then the backing beans are updated with the values and vice versa. So in other words, if they type in something that is a number when letters were expected, and then there's of course in your backing bean there's a field there that corresponds to that, it simply will not be updated until the conversions and validations happen properly. Okay, so what this is doing is it's protecting your model from getting bad data put into it. Once the process has passed the data through, then the application logic is invoked, and then that's only when the state gets updated. And so if you are looking at this page for the first time on the server side, then of course these data structures have to be built up. However, for any subsequent requests, which could be either because errors occurred, or you could build your application such that it's more like a single page application and keeps coming back updating components of a single page. In any case, in that case, the state doesn't have to be recreated, it is simply updated, and then the actions can go on. So during the render phase, the view is composed and in a form that's appropriate for that particular request. So generally speaking, that would mean generating HTML for a browser. However, it could also mean sending back data in textual format. You could send back a single number. You send back a 0 for false and a 1 for true, or vice versa. Or you could send it in a more structured way using XML or JSON data formats. You could send binary data like PDFs, Excels, or audio, video files, graphics, and so on. All of those are part of the rendering process. You also, as I said, have the ability to not go through the entire process if you don't want to, and that's in fact what the Ajax JSF tag is used for in this particular case. I'll talk more about what Ajax is all about. But essentially what it is, it's a way of using JavaScript to request partial updates of pages. The original way that the web worked was that if a user made a request, then the entire page had to be recreated and sent back with any changes on it. Nowadays, a lot of the time, the browser only makes requests for particular pieces of pages, and the browser will maintain the basic page layout without having to recreate it each time. That's essentially what the Ajax concept is used for. JSF has this built in. Prime Faces has an even nicer version of this Ajax tag. And using this, you can actually be much more fine-grained to say which of the components should be executed and rendered. So you don't necessarily have to send back entire pages. Many UI components to pick from. These are the actual Java names for the classes. As a command, that would be either something like a button or a link. There's the form that the the fields, the HTML form that these other fields, these other widgets live in. Display graphic. There are input fields of various kinds. There are error message fields. There are panel widgets, such as panel grid, that are used, and there are other ones of these, just to get you an idea. Generally speaking, you don't have to usually work at this level. You are accessing these things through the JSF tags themselves, like these. As I said, one of the benefits of JSF is that it uses a newer rendering engine. That is what these facelets are all about, and it builds the views from these widgets, and it also now has a templating facility that allows you to create views from fragments. The facelets are essentially XHTML with special tags, and then the libraries that we're using from JSF, the basic ones are called core, HTML, and facelets. Core are the custom actions that are independent of any particular rendering. The HTML ones, those are the most common ones you'll use, are all of the standard component, UI component objects. Facelets are the ones that you use for actually building the templates and then creating the views from those. And then, as I said, occasionally you will use the JSP standard tag libraries because they still, even though they are originally from the JSP world, they still have some functionality that are useful. As I said, particularly, for example, the FN JSTL library has a lot of string handling that you could use to on your pages that you then don't have to do in Java on the server side. So here's the shell for a JSF page. Pretty standard. You have a head and you have a body. This is all HTML. However, you notice they all are the form of H colon something, F colon something. Those would all be the JSF versions of the same thing. So here's one. This is actually a facelets template. You'll see that the parts in blue are actually referring to essentially parameters that are going to be put into the template. In other words, the template will have a standard look and feel, standard shape, standard coloring based upon the CSS that you use, etc. And then you can simply refer to this template, and then you would fill in, for example, the section called header, or your page would fill in the section called messages. And those would take your data that represent those two things and stuff them into here, and that's the way your page would be created. So here's a simple example of that idea. Here's a basic layout. This is the CSS is creating these shapes. I'm not showing that, but that's essentially how this is done. And then these divisions, here they're called, for example, the content container, the footer container. Those are standard kinds of ways of describing these. You can name them whatever you want. And you'll see that you would essentially be putting your main content into the content container. The menus would be going into the navigation sidebar. The standard footer, if you wanted to update that information would go there. So that's, again, the basic concept behind templating. So here is the other side of the templates. This is a page that actually uses it. You will use a UI composition command to say, what is the template I'm using, and here is the value that you're looking for that I am going to supply to you. So here is the content section, and everything between the UI define and the /UI define there, referred to as content, is going to be substituted into the template. Okay, basic, straightforward idea. And by the way, you'll notice that each of the areas, content areas in the template have default values, and that's exactly what's appearing here, just as placeholders. In this case, because we actually used the template and we redefined the content area, then whatever we put in there is actually going to go into the actual output. Page navigation, as I said, it's a set of rules in JSF for picking how the next page is to be displayed after an action happens. The navigation can either be implicit or user-defined, what you might call explicit. Implicit navigation means that you're not using any external configuration files to define the movement through your application. There are, as I said, basic rules for how this works. And the most basic rule is something like this. When you add a component like a command button, command button is a JSF tag that generates an HTML button. It has an action attribute That action attribute is where essentially, generally speaking, you are trying to go next. Doesn't have to be literally, but if it's assumed, if it returns a value, the value has to be a string. If the value is a string, then it's going to be interpreted as where do I go next? And in the simplest form, it's simply if it returns a string with a value of page 2, then what's going to happen is if you say nothing else, you have no other navigation configuration set up, it's going to attempt to go to page2.xhtml. That's the default behavior for this. But you can actually do a lot more interesting stuff if you do use the navigation configuration files. So this is the basic idea. So here's your button. It would have the word submit on it. If they clicked it, it would send to the server side the string logout as the action parameter. That would be interpreted as in this case, this is a direct string here, so it means that look for logout.xhtml. There's no ambiguity with this. However, more typical is you might have an expression, an EL expression where the action goes. So for example, something like at the bottom, in other words, if they click submit, then the action is whatever userbean.whereToNext returns. So the idea would be this: your bean would have some conception perhaps of where you are, and then it would have some conception of where you should be going next based on that. And what the user bean where to next routine would return is actually a string, and the string would actually then determine where you go to next. Now, as I said, that's the basic way it works. If you want to be more sophisticated as to how your navigation works, then you could use these navigation rules in your faces config.xml file. I'll leave it to you to read the chapter on navigation in the core JSF book, which describes this very well. But essentially the idea here is that each of these rules is going to describe some condition. It's a sort of like a big if-then testing structure. So you can give it a description. That's up to you. That's just text. And the first thing it says, if you're coming from a particular view ID, so in other words, this is if you're on a particular page, essentially that's the first if. Then you would look at the navigation case, and you can see there are several different rules in here. You can have multiple ones of these inside of a navigation rule. You might say, which action am I coming from, or which outcome, because there's the if you're using H colon button as opposed to H colon command button, the command button generates a post, the H colon button generates a get. So in either of those cases, you can see where you were coming from, and then you could add other if conditions to this, and then you would say, well, where am I going to in this case? So that's the idea here, is that there's this if-then testing here in order to say, if I'm on that page but I return this action, and if this is true, then go to that ID. So you see, you can actually make for some pretty sophisticated transition rules in your navigation. So here's an example. If you were coming from the view ID called greeting.xhtml, that would be an example of an ID, and that ID returned the outcome success. That doesn't necessarily mean it's looking for success.xhtml. This is simply a string. Then you would go to the view ID response.xhtml. Now, as I said, in generally speaking, if you had none of this here, and you had something when they press the button that returns success, then without all of this, then it would simply look for success.xhtml to go to. However, as you can see, this allows you to come up with a much more rational way of moving around your application. So for example, if you have an error condition, you can simply say, if I'm on this page and the error condition was returned, that is, the outcome said error, then I should go to a standard error page. This would allow you to do that in one place here without having to say that every single time on every single page. So that's essentially the idea. So here's a simple example. Ignore the fact that these say .jsp. This was an example I reused from something else, but just imagine that these are JSF pages. So you can say, for example, if you try to log in and there's no and you manage to log in successfully, that would be the welcome JSF page. If you log in, but for example, the username is wrong or the password is wrong, then you would generate the page with an error message. So essentially what happens in this is the request comes in, it gets parsed by the lifecycle manager, the component tree, the UI component tree is created, all of the validations and conversions are done, etc., etc. And then ultimately, assuming there are no problems, it generates, it renders the HTML, which then goes back in the response. So here's an example of a more JSF style page. So there are actually many things on here that we can talk about. I'll just mention a few. You see the f:\view locale. f:\view used to be much more necessary than it is nowadays, but I think it's useful for this reason alone. If you want to use it, is the idea of you can easily specify the different locales, that is the languages and the symbols that are used with this f:\view statement. And this would allow you to very easily change from one language to another. The entire page can change if you're doing it properly. But regardless of that, then we've got head and body sections. You notice you don't actually need 100% the h:\head or h:\body, but generally speaking you would use those, but you can intermingle them like this, generally speaking. However, we are going to use special pieces of the JSF tags for the form. So h:\form is got a panel grid. This is how the basic layout is done. This is not the sophisticated layout of the entire page, but in this case it's something we do a lot. That is, create a label and then a field, a label and then a field, and etc. Okay, it also allows us to then handle errors in a reasonable way. So that's what the panel grid sort of does. Command button in this case is as I said, it's a post request. It'll say login on the button, and then when it's pressed, the user the bean called user, which has either a authenticate method in it, or an authenticate field in it, in which case it calls get authenticate, is actually the action that happens there. And then based upon what happens from there, the output text if there was a user error in this case, this is one way of generating errors. In fact, there are more sophisticated ways of doing that, as we'll see. Then we have, just to give you a basic idea of what happens, is this is a section of the UI component tree that would get created. So here the form would contain the panel would contain an input component widget for the name of the user, one for the password, one for the submit button, one for the label, one for the other label, etc. So you can see this is just a little piece of a much bigger tree representing the whole page. And what happens is then if you look at the right hand side, this is your JSF over here, and the JSF actually anything that's static text in the sense that it's not JSF, but in this case just HTML, would simply go across to the left as HTML. If it is in fact JSF, then it gets interpreted and based upon the contents of the tree and everything else there and the current values, then the JSF manager actually parses that and generates pure HTML plus CSS plus JavaScript. And then at the bottom you can see there's also basic static in the sense that it doesn't need to be interpreted, it's already HTML. So again, this goes back to showing the point I was trying to make. If you look on the browser side from a JSF application and you do a view source in the browser, you're not going to see necessarily anything that says that it was in fact JSF that was being used, because all you're going to see is standard HTML, standard JavaScript, standard CSS. Now the naming conventions and all of that might for the IDs of each of the components might look kind of weird because they're being generated automatically to be unique, so it would perhaps look a little strange, but in fact it would be perfectly standard HTML. So if you were to, here, this is an example of what I just was pointing out, this is the rendered output from your JSF page based upon that little form. This is actually what the browser gets from JSF when the rendering happens. And you'll see there's a lot of things in here. There's these funky ID names, the underscore ID 0 : name, etc. Things like that. There's a hidden field if you go all the way down to the bottom where the blue text is. Hidden fields are part of HTML forms. It allows you to send data to the server from the browser side without the user ever knowing that it's there, unless they go to look for it. Of course it's visible if they want to see it, but this is a way of communicating back and forth between the browser and the server that the user has really nothing to do with. So this is a way of maintaining state or communicating state information back and forth between the browser and the server using just a standard vanilla HTML syntax. So again, what you're seeing here is what the JSF system has parsed and converted from the JSF Tags XHTML page that you created. So there are 6 phases in the JSF lifecycle: restore view, apply request values, process validations, update model values, invoke application, and render response. So what we'll do is we'll take a break here, and we're going to pick this up in another video. So we'll be back shortly.